Welcome, everybody. Hi, my name is Jennifer Griffith, and I work at NWMOA, which is the Northeast Waste Management Officials Association. And I believe that you should be seeing the NWMOA website. Raj, are you seeing the NWMOA website on your screen?
Yes, I can see.
Okay, good. So NWMOA is an interstate association. The 6 New England states, New York and New Jersey, work together, the waste programs, and that also includes the waste site cleanup program. So these webinars have been organized through that, that group, and we are, the focus of the waste site cleanup program is mainly on training of state staff. And our training, we decided to open it up to the general public so that everybody kind of can get on the same page and hear the same information. So one of the priorities for NWMOA also for many years now has been PFAS. So today we're kind of combining those two priorities, PFAS and training, to hold this webinar, which we're focusing on AFFF, or what does the A stand for? Aqueous film forming foams, which are used often for firefighting. So today we have 3 presentations, so we're going to have a little bit shorter presentations than we normally do. There are a lot of people on the webinar today attending, so we will be having to have written questions. I will be trying to monitor the question box and ask questions. We'll have questions after each presentation. So you can type questions in at any point. You don't have to wait until the presentation is over. You can, like I said, present at any point. So a part of the reason why I'm showing the NWMOA website, so you can read yourself what NWMOA is, but also to show after the presentation, after today, at some point within the next week, the presentations will all be posted, the PDF, on the NWMOA website. So I'll just show people how to navigate there. So you're on NWMOA.org, then you go to Waste Site Cleanup, and then you pick Events. And then these are the furthest one in the future is at the top, so you have to sort of scroll down. Here's the other webinars we have coming up in this series, and then you get to past events. And so this will be a past event, and you'll be able to click on that. And like we just had a webinar last week on uses and alternatives. Here's this, and then here you click on the people have the presentations for those. So that's where you'll be able to find these presentations. I will also send out a link afterwards when the presentations are posted to everybody that attended today, the link directly to the webinar. But there's a wealth of information on the NWMOA website on PFAS, but also on other topics. All the webinars we've done, all the trainings that NWMOA has held, the presentations are posted on the website. So there's a wealth of information. So with that, I'm going to introduce our first presenter, and we'll get going. So I think I've covered all the logistics. Yeah, so type in questions at any point, and presentations will be posted. Sometimes it takes a few days, though. So our first presenter is Raj Kamal Singh, Dr. Raj Kamal Singh. He is a postdoctoral research associate in the Department of Defense Plasma Research Laboratory at Clarkson University. He works with Professor Thomas Holson and Selma Medovic-Thagard, sorry about that, butchering those pronunciations, at the Department of Civil and Environmental Engineering. So he's going to talk about his research into AFFF, but his current research focuses on the characterization and remediation of PFAS from different contaminated water sources using plasma. I'm going to just make him the presenter. We had a little bit of technical difficulties earlier, so hopefully he'll be able to show his screen. So remediation of PFAS from different contaminated water sources using plasma and other treatment technologies. His team recently developed a mobile plasma trailer for the treatment of PFAS contaminated groundwater, which was successfully demonstrated at a U.S. Air Force base. So with that, Raj, are you needing me to, did you email me your presentation? Do I need to show it, or are you going to be able to?
Okay, let me click this. Start sharing.
Okay. Sorry about this.
Can you see me?
Your screen popped up, or you need to close some things so you can find the pop-up that says that you accept screen sharing or something?
I accepted. I don't know for reason is I'm unable to click to start sharing. Okay. I don't know. It's hard. Can you please? I shared my presentation with you.
Okay, I don't think I have an email from you with the presentation. Sorry. Should we move on to the different presentation and come back?
Yeah, please. I'm sorry for that.
Okay. All right. We will, sorry, we'll switch order here. Sorry, everybody. We'll have Kate Winnebeck. Kate, are you all okay to go?
Yeah, I'm all set to go. I can go.
Okay. All right, I'll make you the presenter. So now I'll introduce Kate, and we'll come back to Raj. Sorry about that. Kate Winnebeck is a senior project manager at the New York State Pollution Prevention Institute, which is located at the Rochester Institute of Technology in Rochester, New York. Her work focuses on evaluating environmental attributes, recyclability, and human health effects of products and performing life cycle assessments to assist companies in quantifying their environmental impacts. Kate leads the Institute's Emerging Contaminants Program and was the lead author of the per and polyfluorinated substances in firefighting foam report that the IC2, the Interstate Chemicals Clearinghouse, that's what the IC2 is, published in April of 2019. So with that, Kate, take it away.
All right, thank you, Jennifer. So as Jennifer mentioned, I'm going to talk about PFAS and AFFF today. Can you hear me okay?
Yes, I can.
Okay, good. I got some errors saying you can't. Okay.
Oh.
That's all right. We'll keep moving forward. There we go. So for those of you that are not familiar with the New York State Pollution Prevention Institute, we are headquartered at RIT in Rochester, New York. And our goal really is to reduce the environmental footprint of New York State. So we do a lot of work with typically small, medium-sized companies. We have a couple different focus areas here that you can read on the slide. I lead our emerging contaminants program. So I tend to work kind of in collaboration with the State Department of Environmental Conservation and helping to identify sources of emerging contaminants. And PFAS, of course, is one of those. So that's kind of how I got involved in this project. So what I'm going to do today is really review the per and perfluorinated substances in firefighting foam IC2 report that was now done 2 years ago. We'll talk about the project goals and objectives, the performance specifications that we looked at, fluorine-free foam that we identified, and then I'll kind of end it with some ongoing work or kind of what's been going on since we did this report. So the IC2 report, it's on their website. The link is on here. So it's free, you know, anyone who'd like to read it. So again, we did this for the IC2, the Interstate Chemicals Clearinghouse. And really, I led and coordinated a team of about 10 IC2 members. So this is folks across the country who work together on this project. So there's also, the report is online, and we have a list of fluorine-free foams is also online at the same website. So the goals of this project, really we had three main goals. We wanted to understand performance needs and specifications of firefighting foams and the use of PFAS to meet them. So we were curious, were there ways to meet goals, these performance specifications, without the use of PFAS, or was PFAS actually specified within the performance specifications themselves? And then we wanted to identify and characterize alternatives to long chain fluorine containing foams. So are there existing fluorine-free, quote, fluorine-free foams? What are they? How can we characterize them? And then also kind of pull together agencies and researchers focusing on the use of alternatives to PFAS in foam. When we had kind of this small group that got together, we realized we all kind of knew of different researchers and agencies, and we really wanted to pull everything together in one place and have that be a resource for folks to use to find, other agencies, all researchers in one area that are working on this work. So this is kind of a very high-level summary of the results. We compared performance specifications. I'll go into that in a little more detail. We summarized the current restrictions. There are some restrictions. We looked worldwide. So, for example, Australia has some restrictions that are not in place here. So we looked kind of worldwide to see what those restrictions look like. We found over 90 fluorine-free water additives from 22 different manufacturers. So this is what we would consider fluorine-free foams. We highlighted and summarized some research and alternatives assessment work. And then there were some conclusions, research needs, and actions at the end. And it's really exciting to know that, again, this report was released 2 years ago. So there has been some work done based on those research needs and actions that we developed as part of this project. So a large reason why we did this work is as a precursor for an alternatives assessment of PFOA and PFOS and firefighting foam. So there were folks very interested in doing an alternatives assessment, so a way to assess safer alternatives to chemicals of concern in products or processes. So they really wanted to do an alternatives assessment of these, quote, safer foams or, fluorine-free foams. But we really needed to step back for a minute and take a look at the landscape and say, okay, what foams even exist? What are the performance specifications that the foams have to meet, et cetera. So this was kind of intended to be a precursor for an alternatives assessment of foams. So the performance specifications that we evaluated and characterized, there's a much larger kind of characterization and details about this in the report. So I encourage anyone who's interested in the performance specs to refer to the report itself. So we found that 7 did not require PFAS. So the performance spec itself does not mandate a fluorinated substance. It just has, specifications that the foam must meet. The U.S. MIL-SPEC, so the military specification, and the International Maritime Organization specifications both actually required PFAS. That was a mandatory requirement. But then the MIL-SPEC is the only one that also limited content. So while the first kind of 7 there, the Australian through the UL standard, did not require PFAS, it also did not limit any kind of PFAS content either. So what's interesting is when we start talking about the military and why, this is so important that the military requires PFAS, 75% of all AFFF, so all firefighting foam is in the US is used by the military. Prior to 2018, the US Federal Aviation Administration had the MIL-SPEC incorporated into their requirements. So it required major US airports to use fluorinated foams on site as well. So we had airports and military bases as well using fluorinated foam. And now the US Department of Defense is spending a lot of money and doing a lot of work investigating PFAS contamination in and around military bases, and also doing a lot trying to find alternatives that do not contain fluorine, but that are able to meet the kind of rigorous military specification. So when we were identifying fluorine foams, the goal was to really come up with a comprehensive, up-to-date list to identify alternatives for specific foam applications. That was what we intended to do. And so the sources where we got, manufacturers and products that were considered fluorine-free came from the IC2 Alternatives Assessment Workgroup members. Many members we found kind of had their own ad hoc compiled lists, and we reconciled those. There were, some that kind of everybody knew about, some that only a few folks knew about. And then as we were working on this project together, the work group members added to the list throughout the project. So as folks, became aware of others, we added those as well. At the Pollution Prevention Institute, we had done a supply chain assessment of Class B firefighting foams for the New York State Department of Environmental Conservation. We did that back in 2018. And at the time, we identified a number of fluorine-free foams, or what we expected. They were kind of marketed as fluorine-free foams and manufacturers. So that was a good starting point for us as well. We looked at organizations that were working to develop and research fluorine-free foams, including, so here's kind of a short list. Again, there's additional information in that report for those that are interested. We looked at the OECD, UNEP Global Perfluorinated Compound Group, US DoD and US NREL, the Naval Research Laboratory. They have a lot of good information on research into fluorine-free foams, a lot of technical information. The US EPA, Washington State, the state of New Jersey, again, the Australian government. We looked at, the Petroleum Environmental Research Forum, Clean Production Action, who was working with Toxic Free Future in King County and Washington State at the time. They were doing some work with us as well. We did an online search for patents to identify foams and surfactants. We found 4 patents. Again, there's more information and links to those patents in the report. We just did, online searches, so your basic Google search to try to find additional products. And then we looked at the DoD qualified products database. I mean, this was all kind of happening in tandem. So this is, before we realized that you must have a perfluorinated compound to meet the DoD requirements. We looked in their qualified products database, and of course, all products were short chain fluorochemicals. So everything that meets the mil spec is a fluorochemical. So we didn't find anything that way, but we definitely looked into it. So we collected data in August in 2018. That was kind of the first iteration. And then we released an update in April of 2019. We had 91 products from 22 manufacturers, plus 13 training foams, which is interesting because, we found that, especially with fire stations, local fire stations, they were using fluorinated firefighting foams, and there's no regulation that requires them to use a fluorinated firefighting foam. So we found a good number of training foams, so they can be used in training exercises as a replacement. The main source of product information was manufacturer websites. I mean, that's the best that we had to go on at the time. We used safety data sheets as well. We found the products they're manufactured in multiple countries. So we had products from the US, Canada, the UK, Spain, France, Germany, Belgium, and Sweden. We collected safety data sheets for each product. Where they were not accessible online, we requested them from the manufacturer. We had some manufacturers that would send, technical data sheets or results of performance tests. Any technical information that they sent us, we reviewed, and then we added that to our spreadsheet. So our spreadsheet, you can search and see product and manufacturer name, the country where they're manufactured, any performance specifications that the product meets. So, that list of performance specifications a couple slides back, some foams indicate which of those they meet. So we captured that as well. The product application, product description, and then the CAS number, name, and % of disclosed ingredients in the product. Now, again, these are, this is information from the manufacturer and from the safety data sheet. So I highly suggest anyone who's interested in, what these fluorine-free foams, definitely look at the list, but confirm product information directly with the manufacturers. May have changed since we developed the list or since we updated the list, or they may have some, different or additional information than what we were able to collect. So some more limitations of that list. We know that the ingredient lists are incomplete. It's also the best information we have. So the ingredients are from the safety data sheets. Many ingredients are protected as confidential business information, so they may not all be listed. There are many researchers and those in the firefighting foam industries, and even those in kind of the firefighting industry, have raised concerns about foams that are marketed as fluorine-free actually being fluorine-free. And there's some kind of discussion around, at what point does it become free? What level do we need to measure down for it to be considered fluorine-free? So something to think about when looking at fluorine-free foams. There's a lack of independent performance testing. So some foams we found the manufacturer would release, here's our results of our performance testing showing that the foam, meets a performance specification, but there's not a lot of independent testing. It was manufacturer testing showing that. And then lastly, ecotoxicity and human health impacts of most fluorine-free foams and their ingredients have really not been characterized. So there's not a ton of information out there on the alternatives themselves, right? On the chemicals that they're using and what their safety profile looks like. So lastly, I just want to mention some ongoing work and work that's kind of happened as a result of this project that we did. We have, where'd it go? I mentioned the US DoD. So they released a update in March of 2020 from their PFAS task force, and they still do not have a PFAS-free foam that's met performance specifications. They have spent tens of millions of dollars and are continuing to try to identify a product that can meet their requirements without having any fluorine. But they've changed. I mean, this is a good move. They are now only using AFFF to respond to emergencies. So any land-based testing or training is not being done with fluorinated foams. And there's currently 615 Department of Defense and National Guard sites where PFAS use or potential release is being investigated by the Department of Defense. So they definitely have some ongoing work. There's the OECD UNEP Global PFC Group portal, so that has great exchange of information on PFAS. The Interstate Technology and Regulatory Council, ITRC, has a really great series of fact sheets on the latest science and technology for remediating PFAS contaminated sites. The Petroleum Environmental Research Forum, so they are also researching kind of fate transport effects of fluorine-free foams and short chain foams. The Dallas-Fort Worth Fire Training Research Center has been doing some performance testing of fluorine-free foams. Clean Production Action has done an alternatives assessment of fluorine-free foam. The EPA has a PFAS action plan with a lot of work around PFAS. So you know, long story short is that there's a lot of work currently still being done for PFAS and HFF. So I will leave you with that. And there's my contact information. If there's any questions, Jennifer, you want to do them now?
Great. So thanks so much, Kate. So for people that might have joined a little late, where our presentation order got a little switched around and Kate went first. So yes, so one is, maybe can you show, we can see your screen, so maybe you can navigate and show people where they can find the resource?
Sure.
Yeah.
Can you see my screen now, or did you pause it for a minute there, Jennifer?
I didn't pause it, no. Saw you reduced your slides. So people are wondering where the...
Okay, hold on. It's not one.
So we see...
Okay, hold on. What do you see now?
Your slide, yeah, we see your slides, but not in presentation mode.
Okay.
But we don't.
Well, I'm trying to get out so that I can share. It won't. I'm trying to show.
That's okay. I can maybe do that. So let's see. Here's some other questions. How many of the alternatives have you identified have been green screen certified?
That I do not know. I do not know. I would have to go back and look at that. I know that Green Screen has their certification and they list what has been certified there. I have not cross-referenced to see if their products are on our list.
So can people, when I send the link to the slides, when they get posted, I will also send a link to where the spreadsheet is. I think, I know you can get to it from the IC2 website, but I don't know if is it also on your P2I web page?
Not.
Or?
So Jennifer, if you want to navigate to it, it's on the IC2 website. Well, it's actually easy. It's IC2 and then it's publications and it's right there on the publications page.
Okay. Let's see. I will show my screen. Everybody will see everything. Okay, so I'm on the NEMOA website, but I need to go to, so it's www.ic2.
It's the IC2.
Oh, the IC2. theic2.org.
Yep. And then if
you... And then where is...
Well, I'll try about. These are publications.
Oh. All right. Oh, maybe, yep, publications.
Yep. And then there's...
Right here. Right?
Yes.
Compendium
so that's the report.
Foam.
And then the foams is an Excel sheet is right underneath it.
Yep. There we go. So hopefully people can see. I'll just increase the font here. So yeah, dic2.org, and then you look under About IC2, and then there's a publications link, and then it's down here. So this is where you can find it. All right, with that, I have slides from Raj, so I will show them, and he will just help me to advance them at the right time, hopefully.
Thank you, Jen.
Okay, so I think we're ready to go. I already introduced Raj, and yes, somebody else is asking about the slides being presented, available, and they will be. Okay, take it away.
All right. All right. Good afternoon, everyone. I'm Raj Kamal Singh, postdoctoral research associate at Clarkson University. Today's talk, today's presentation, I'm going to talk about what is saline aqueous film forming foam and does it matter? with this, let's go next slide.
Okay.
All right. So this will be the outline. I'll closely follow throughout my presentation. So I briefly talk about PFAS. Hopefully, most of the audience know about PFAS. Then I'll be talking about AFFF characterization from different industrial formulations, what happened upon AFFF oxidation, and then what could be adopted as treatment approach if something is contaminated with AFFF. And then I'll briefly talk about plasma-based water treatment. That's what we do in our group. And finally, I'll conclude my presentation. Next slide, please. All right, so per and polyfluorinated alkali substances are the synthetic chemical compounds. We can broadly subdivide into perfluoroacids and then precursors. Perfluoroacids can be either carboxylic acid or sulfonic acid because of their terminal functional group. These compounds are surfactants. The problem with this compound, they have polyfluorinated carbon-fluorine bonds, so that's why they are stable in nature and then very difficult to degrade. The precursors are those compounds which can be transformed into perfluoroacids. Upon oxidation, it can be a natural process or it can be any treatment regime, which based on the oxidation. For example, here we can see 6,2-FTS is one of the precursors, which can be transformed into perfluoroheptanoic acid or hopefully probably in some other short chain perfluoroacids upon the oxidation. Next slide, please. All right. So then what are all the sources of PFAS? The primary source of PFAS in the groundwater or water contamination is aqueous film forming foams. These foams is being widely used for firefighting activities at DoD sites, commercial airport, industrial facilities. There are other sources of PFAS in the environment, such as industrial spills, dumping wastewater effluent, leaky landfills, and disposable of household products that we use in our day-to-day life basis. These PFAS are characterized across US and other parts of the world, and it was found that the concentration of PFAS in groundwater are 3 to 4 orders higher than the US EPA health advisory concentration. Long chain PFAS are bioaccumulating and toxic. Many studies reported that, and that's why the C8 foams is now phased out to further manufacture. And as I said, they are very recalcitrant because of carbon-fluorine bond, and US EPA are now requires to free all this foam from long-chain perfluoroacids. Next slide, please. Okay, so this slide shows the overall concentration characterized across the United States, and we can see there are so many drinking water where PFAS have been reported, and also at different military sites. So at present, US EPA do not have any standard, but they do have health advisory concentration that is 70 nanogram per liter for PFOA and PFOS. In recent few months before recent years, many states of United States came up with their standard, and which is more stringent. For example, for Massachusetts, came up with a standard 20 nanogram per liter for 6 PFAS. We can see that range from C6 to C10. Next slide, please. All right, so what is my motivation to do a study on the PFAS? Okay, if these contaminants are present in the environment, finally the fate they are reaching to drinking water and cause the problem of human being or the environment. So what are the treatment technologies we have? Practical applications on practice we have activated carbon and ion exchange system, but the problem with this system is the short breakthrough time and then disposable of another problem. What about the spent adsorbent? That's the problem. Another problem in ion exchange system, they generate a concentrated brine solution which contains huge concentration of PFAS. Then again, disposable is a problem. The only thing what we can do and practice now to incinerate those PFAS, but that option is expensive. Advanced oxidation processes, they are in lab they're shown to be effective to treat PFAS, but they are ineffective or prohibitively expensive for the practical application. In recent times, in our group, we showed that plasma is a viable option and can be leading technology to remove PFAS from the water. The literature gap, there is no treatment technology available to degrade PFAS at large scale, and there is no efficient treatment options for aqueous film forming foam. So we need to solve this problem. We need to solve the problem first. We have to know the problem, how much these PFAS are present, and then when I was doing this research, my main motive is, can a pre-oxidation option prior to plasma be more effective or cost effective for the treatment of PFAS? Okay, so with this motivation, now I'm moving to my next slide. Can you please go to, yes. So first we characterize 4 different industrial formulation AFFF samples, and here for this plot I subdivided this plot into 3 parts. So PFAS precursors, short chain perfluoroacid, long chain perfluoroacids, and then Y scale is log scale. So one thing to be noticed here, in all the forms, we notice high concentration of 6,2 FTS that is present in all the forms. Also, it contains a significant concentration of short chain perfluoroacids and the traces of long chain perfluoroacid. This long chain perfluoroacid supposed to be not present in these forms because they are meant to be C6, but we still detected those in little concentration. The problem become worse more once we characterize total fluorine and total oxidizable precursors. So as we can see here, total fluorine concentration is 400 to can you please go? Yeah, 400 to 6,000 milligram per liter, and total oxidable precursor is in grams, 1.5 grams to 10 grams per liter. So ultimately, these precursors will be transformed into perfluoroacids upon the oxidation, which can cause a further problem to environment. Next slide, please. All right, then we compared different, so I characterized 2 different forms, C8 and C6, and we can see this C6 represented in blue color, C8 in yellow color. So it has again concentration of this PFAS is very high. Noticeable thing here in C6, one of the C6, still we detected high concentration of significant concentration of C12, C14, C13 perfluoroacids, and of course C8 has very huge concentration of this long chain perfluoroacids. So this explains the problems in using the currently problems of using current industrial formulation AFFF. Can you please go to next slide? All right. We also analyze AFFF rinsette from the truck which transport these foams, and then they just wash, and that wash water we characterize what concentration of perfluoroacids present in this rinsette solution. So in fact, in those water also we can see significant concentration of different perfluoroacids were analyzed. Can you go to next slide, please? Okay, so now I'm coming. Okay, so we do target analysis, analyze 25 to 30 analyte at a time. But what happened once these forms will oxidize? For example, here so these 3 form we oxidize using heat activated persulfate upon 100 times dilution sample, and then we see the significant increase in 6,2 FTS concentration and then increase in short chain perfluoroacids. This is understandable. Okay, short chain perfluoroacid concentration increased because these precursors transform into perfluoroacid, but 6,2 FTS concentration was also increased because this 6,2 FTS has its own precursors that are present in these forms. Can we go to next slide, please? Okay, then we optimize the heat activated persulfate and see how much dilution we need in order to completely transform these perfluoroacids. For this case, we consider 99% conversion of PFAS precursors to perfluoroacids. And in order to completely oxidize all these precursors, we need to dilute the sample 1,000 and 10,000 times. And also we need to use huge concentration of persulfate in order to completely transform these precursors into perfluoroacids. Just imagine if these forms are present in the environment, it will take years and years to completely oxidize these precursors, and then it will transform to perfluoroacid, and finally we understand the real problem. So that's the hidden problem. Any treatment technology should target that problem, and then we decide any treatment regime. Okay, next slide, please. Okay, so this is just to get feel what happens upon the oxidation. So this is the first plot, left-hand side. We can targeted analysis when we found the concentration of these precursors are less concentration, and also short chain and long chains are like low concentration. But upon the post-oxidation, what we can see, we transform all these precursors to perfluoroacid, and we can see huge jump in short chain perfluoroacids, and then appearance of some of the long chain perfluoroacids. So any treatment technology should, if apply, we have to target this post-oxidized concentration, not the just pre-oxidation pre-oxidized AFFF form. Also, we did some non-targeted analysis to find out what all the different unknown precursors present in that, and we injected a sample in QTOF, and we found one of the unsulfide samples we diluted 1,000 times, and then we saw a huge peak of unknown compound that was for M/Z 586, and then we figured out this M586 can be transformed into 60 OFPS upon the oxidation. Similar to this, one of the unknown precursor, we detected different M/Z, and this mass is reported. So these compounds, you can see as per the molecular weight, they are larger compound, and then upon oxidation or the fragmentation, they can transform into precursor or some of the perfluoroacids. Next slide, please. All right, so now I'm moving to the next segment of presentation, just to get a feel what happens in any treatment technology when we intend to treat these forms. So, but if you want to adopt any treatment technology, so there should be some approach. So what we adopted in our research, first we characterize different forms. We did targeted, non-targeted analysis, need to characterize TOP, TF, and then we can apply a pre-oxidation option. For example, we can use heat-activated persulfate or other oxidation options. Of course, we have to optimize that pre-oxidation option before moving to plasma treatment, where we can completely degrade PFAS present in aqueous film forming form, and we can optimize, of course, plasma parameter in order to completely mineralize the PFAS. Next slide, please. Okay, so as I was talking about the plasma-based water treatment, just I want to introduce what's a plasma. So plasma is a fourth state of matter which contains various neutral species, positive, negative ions, electron, excited ions, excited atom, and some other radicals. Plasma can be generated in the lab, either above the liquid or inside the liquid. It generates both oxidative species and reductive species. By utilizing both oxidative and reducing species, we can efficiently degrade the PFAS from the water. And plasma also can cause some physical effect. For example, UV light, condense shock waves, and locally high temperature, which can thermally degrade the molecules, PFAS molecule. And the most important thing, plasma-based water treatment do not require any chemical additives and produce no residual waste. Next slide, please. So to understand how efficient the plasma-based water treatment system, so we obtained 13 different IDW sample, investigation derived waste from Air Force Base, and we then treated in one of our pilot scale plasma reactor. And what we can see here, the treatment efficiency for long chain PFAS is very good, and also we can see for PFAS precursors, the efficiency is really good. Also, we shown that we could remove around 55% of total oxidizable precursors in very short treatment time. The right-hand side plot, we can see PFOA and PFOS removal. That's combined PFOA and PFOS removal. And what we could see within 1 minute of treatment time, we could reduce PFOA and PFOS concentration to below US EPA health advisory concentration, that is 70 nanogram per liter. So this technology is really good, and we can remove efficiently PFAS from the contaminated water. Next slide, please. then we install this mobile plasma reactors and one of the trailer developed by university, and then we can see 2 reactors are stacked to each other, and this is like some of the inside view. We can see the collection tank and reactor side. Can you go to next slide, please? Yeah, so then we tested this reactor at one of the Air Force Base, Wright-Patterson Air Force Base, where we treated 350 gallons of PFAS impacted water, and we efficiently we got removal like similar whatever we got in the lab, and we treated. And things to be noticed here, like the cost. Every time when we adopt and treatment technology, the cost people ask, and that's like $0.0067 per gallon, which is very cheap. All right. So okay. So then just to then again, I'm coming to the problem of this aqueous film forming form. So what happens to treat once you want to treat in the plasma without dilution, without diluting AFFF sample? So what we can see, we expected to reduce whatever the PFAS present after some 60 minutes at a time concentration decreases. But what we found, the concentration of all the PFAS increased, including 6-2 FTS. So that again indicate that PFAS precursors cause problem. Even any treatment technology, the best treatment technology, whatever we have, it can cause the problem. So instead of decreasing concentration, we saw increase in concentration of all the perfluoroacids. Can you go to next slide, please? Yeah. So then we diluted the sample 100 times, and then adopted pre-oxidation, persulfate pre-oxidation. And upon doing that, now what we can see, then we can remove perfluorohexanoic acid concentration. Then also this, we can see in the right side plot, PFOA is like PFOA concentration also decreased over the treatment time. And 6-2 FTS, the bottom graph, what we can see upon the oxidation, pre-oxidation, 6-2 FTS concentration, excuse me, also decreased significantly. Can you go to next slide, please? All right. So with this, I like to conclude my presentation. So with targeted analysis, we found so many perfluoroacids in aqueous film forming forms. They're present. We detected high concentration of short chain perfluoroacids, traces of long chain perfluoroacids, in fact in C6, and significant amount of PFAS precursors. And TOP concentration was huge, like in grams per liter. In all of the forms, we detected 6-2 FTS that was present in highest concentration. So if any treatment technology should apply to treat these forms, they should consider 6-2 FTS concentration. And we optimize heat activated persulfate for this all the AFFF, and we found out in order to complete oxidation of PFAS precursor, we need to dilute the sample minimum 1,000 to 10,000 times, and we need to increase the persulfate dose. Also, we found upon the oxidation, we can increase the significant concentration of PFOA, other long chain PFAS. For example, in PFOA, concentration increased by 700%. And we also identified some of the unknown precursors by using QTOF analysis. And if we want to come up with any treatment technologies to treat these AFFF forms, we need to pre-oxidize in order to make any system efficient and completely destroy PFAS present in aqueous film forming form. Next slide, please. With this, I like to acknowledge my research group where Thomas Olson and Selma Medovic-Taggart, a postdoc advisor, and other people who were instrumental in helping doing all this work, and the funding supports from different agencies. Of course, without this, doing this research are impossible. And thank you. If you have any question, you're most welcome to ask.
Great. That was a lot of information, but also very interesting that these precursors and not having them oxidized can create a lot of problems. So there are questions. I just want to go to something basic, which is that the 4 foams that you did test are not old foams. They're currently marketed foams that are supposedly, you know, C6 or less. That's the way they're marketed. They don't have PFAS in them anymore.
Yeah.
Okay. Let's see. You talked about rinsate and collecting rinsate, and we're wondering, and doing some testing of that. And so we're wondering what was the source of that? What was that sort of trying to model again? What was the thinking with the rinsate?
Right. So the idea of analyzing rinsate, since I mean, even these foams are phased out, C8 foams, but we detected some long chain PFAS concentration in rinsate samples. So I mean, the problem still, we didn't solve the problem, even though it's phased out. If you talk with gallons of C8 foams are just lying there. We need to think how to treat that. We can't just incinerate them. And then if you want to treat them, also we need to adopt a good practice where how not contaminate this carrier or the vehicle which used to transport this aqueous film forming foams. We need to come up with this some treatment options or some of the precautionary measures, because ultimately the workers or something can be exposed to this PFAS. So that's the idea.
Okay. Let's see. When you looked at those products, did you have safety data sheets for those? And was, you know, were the components that you found in them sort of disclosed in their safety data sheets, or this is sort of unknown information?
Yeah, there's unknown information, so we need to characterize them. They don't disclose at the real concentration. Okay. Yeah. Okay.
And then some people just wanted you to dive a little more, because you did talk about the energy use, but if the plasma technology doesn't require any chemical additives, and the products produced from the process don't create disposal issues, you know, they're benign for disposal, but you know, where is the cost in this process, and the energy, and you know, and are we going to be able to scale this up to meet the need for the quantities of material that we need to destroy?
All right. Yeah, I mean, that's a good question. So two costs basically. So whatever the cost is, I mean, shared here is operational cost, which is of course, $0.006 per gallon. Yeah, so you can see here, and this is mostly because of the energy required, kilowatt hour energy we have showed for the different flow rate we employed. So it's if you can see here, basically, just for the normal public, 1 kilowatt hour is 1 unit of electricity. So in worst case, it was like 4.3 gallons of 4 unit of electricity in order to treat the 1 cycle of the water. And finally, the cycle, it's difficult to understand. We converted everything in the gallon of water, how much gallon of water we treated in that much cost. So we convert this electricity cost in terms of dollar. And here in this cost, there's no capital cost involved. But for large scale system, of course, there are so many things we need to do cost benefit analysis in order to come up with the total cost. But this is just operational cost. And yeah.
All right. Well, I think that's most of the questions that have come in. So thank you so much. It's great to have some data on what's actually going on. So thank you. And great things to consider as people are looking for destruction options as well. So so with that, I think in the interest of time, we should move on. We're going to hear about some state efforts to actually go fluorine free and what they found when they tried to actually do that. So I will switch presenter here, and thank you so much, Raj.
Thank you so much for sharing. Sorry, I could not.
That's okay. Yeah. All right, here's Nick. so I need to introduce him. Sorry, I got all confused there. Sorry. So our next presenter, so Shannon Pochu at Connecticut Department of Energy and Environmental Protection, DEEP. She is unable to join us today, so we will just have, but she did work with Nick on the presentation. So we're going to have just one presenter today, and then maybe a couple other people from Connecticut will be able to chime in as well. But I just have one person to introduce, which is Nick Child. He recently retired from Massachusetts Department of Environmental Protection after over 30 years of dedicated work. Thank you, Nick, as I'm someone that lives in Massachusetts. He spent most of his career in the Oil and Hazardous Material Emergency Response Program. And for the last 5 years, he was the agency's Chief Emergency Planning and Preparedness Officer. He's been Mass DEP's lead, working with fire departments across the state on the legacy AFFF Take-Back program. He's also has served as a volunteer firefighter for 30 years, so he knows what he's talking about here. He's also been a volunteer emergency management director for 12 years and the chair and vice chair of the Blackstone Valley Regional Emergency Planning Committee. So with that, I will turn it over to Nick.
Thank you very much. I'd just like to start off by saying that we have a regular cooperative relationship between the New England states for information, and this is one of those types of projects between Mass and Connecticut that has gone very smoothly. So just as background, both Mass and Connecticut recognize that AFFF, current modern AFFF, has PFAS in it. We have one small project was taking samples of current foams in active fire departments and just running them for analysis, and they're coming back as expected, and as our other presenters have said, that it does in fact have PFAS. We also recognize that that the use of AFFF foam is a necessary tool for the fire service to extinguish flammable liquid fires for their mission of life safety and property. And we do acknowledge that that is the priority, but there is usually an environmental impact after the fact. As we have gone out and worked with fire departments, we have told them about what we're working on, and as part of our recovery project, we have also told them that, you know, if they're getting rid of this, the next question is, well, what should we buy next? So part of our project here was to kind of do our own guidance and research to figure out what other choices were out there. And just on the side, there's a picture of that 3M light water. That was one of the original types of AFFF long chain foam, and we found several fire departments found that as that's kind of the what we refer to as like the original holy grail of bad foam. They were finding this under the staircase, in the attic, in the doghouse, just typical fire department kind of thing. Connecticut is formed a next generation foam committee specifically to look into alternatives, because Connecticut owns their own fire trailers, foam trailers. In Massachusetts, we don't. It's held by our regional Homeland Security councils and individual towns. But having Connecticut own their own trailers, that gives them a lot more latitude to decide what product they want to use and how they want to do it. They also invited us to be part of this with the petro industry, with reps from different foam providers, DEP, the Fire Marshal's Office, etc. So Connecticut Fire Academy brought in several vendors to show their fluorine-free firefighting products and to speak and to do a little bit of answers and questions on it. In addition, they also they did some hands-on training with the foams to see how it did what it's supposed to do. It's also part of this issue of looking at a replacement foam is making sure that there's a foam that actually works with existing technology, with existing fire trucks, nozzles, inductors, things like that. It's also that the replacement foam has to meet the NFPA 11 standard and the Underwriters Lab 162 standard as well. So, and as I said, it has to be compatible with the nozzles and the foams on the foam trailers, and that also covers the issue about making sure that, the local fire departments can just plug and play with this. Next one. So this is just an example of some of the field testing on it. It was done just to show how effective it was, how it behaved, so that the Fire Academy can say that, that this was actually, this is a boots on the ground experiment. So for the laboratory parameters tested, so we ended up taking in 6 foams that that were claiming to be fluorine free, and we ran the test on it. These were foams that were purchased off the shelf by Connecticut DEP, as if they were Joe Fire Department. This was not ordered directly from the manufacturer or the vendor. It would just, that way we would know that this was actually what was on the street. Connecticut bought the foams, and we agreed to pay for the analysis using one of our state-funded contractor labs to do the analysis, plus also working with Harvard University and Sterling Analytical to try some other methods of looking at the foam itself. PFAS was compared against 24 components. It's modified by DEP in methodology. It also looked at total oxidizable precursors, top assays of possible conversion of some shorter chain foams into some of the more problematic ones. We were checking for semi-volatiles, inorganics, total halogens, and just as this analysis was running a package cost of about $3,500 per sample run. The shorter version, when we're just doing sampling of AFFF foam for checking what's at the firehouses and such, is significantly cheaper than that. But this was for the whole analysis. And my Connecticut friends, feel free to jump in at any moment. So these were the round 1. These were the foams that we looked at. And then at round 2, we also added some additional foams by some of the police, some of the fire associations. Fire Chiefs Association had asked about some other foams as well. So we brought them along to look at all of these and compare them to each other. We were looking for some objective data on this, and these are the ones we looked at. Now, since we're going to be providing copies of this presentation for you, so you have a chance to look at this colorful chart at your own, and please feel free to ask me questions after the fact on this. You can see how we walked across the different analytical methodologies for each one of these 6 foams to see what was showing. Now, we know that the last one, Firestopper, that is a current PFAS firefighting foam. So we are not surprised to see those particular numbers showing up in it, those components. We also wanted to see which one of them were also kicking out, where the fluorine and chlorine was showing up as well as inorganics. As you can see, they did show up in a couple of points. Also, this methodology is working at extremely fine levels and is extremely challenging in taking the sample and running the samples. So this is pretty cutting edge stuff. It's also that you can see some of the red markings on some of these results, that some of this product was detected in field blanks or in temperature blanks. It's just very, very difficult when you're at these very fine levels. Okay, so I'm going to talk to you about the 2 programs that Mass DEP and Connecticut DEP did for Take Back. Our program started in 2018. I had glorious hopes that this would be a 6-month project to be able to recover as much of the pre-2003 legacy foams. These are the foams which were the longer chain, the older ones. These were the ones that were put out of production currently. So we wanted to make sure that this was not sitting around. They were all put out of action in 2002. We added an extra year to it because they may have been going through they may not be manufactured, but vendors may still be pushing them out. So we used 2003 as the cutoff point. This is also the same number that we were working with the state of New York on, that they used that as their cutoff for legacy foams. It was a take back program, not a buyback. This was for fire departments to voluntarily provide this, and we were not buying the foam from them. We were not buying replacement foam once it came out. That was up to them. It was a partnership, particularly with our Mass Fire Marshal's office. As fire chiefs will probably tell you, when they get an email from me, it's probably some of that crunchy environmental stuff. If they get the email from the fire marshal's office, it's of course something they pay a higher level of attention to. So this was a chance for us to work with our partners in the marshal's office to educate them on what our concerns were and come to a common point. And the fire marshal's office, sent the message out to the chiefs, to the fire associations, etc., to let them know the DEP had this take back program. You just have to call and we'll make the arrangements. So to date, we have just taken and destroyed 100,000 plus pounds of concentrated AFFF. Works out to be about 25,000 gallons of concentrate. The cost to date, as you may have expected, we did not know how much was out there, but every time we went out and said, look, we've got another opportunity here, we would find more foam. Fire departments would be calling us. I got a call, 2 phone calls this week alone, saying that we must have missed your program, but we found 2 or 3 more of these jugs. So we are going out and getting them. And you can also see by the years on this thing, the first year that this program was in was our largest investment in this and our largest cost, and then it has been decreasing since. A challenge that has gone along with this is again, the decontamination, the rinsate issue, and the final disposal issue. For this program that we ran, the vast majority of it went out by our emergency response contractors out to a fuel blending facility in the Midwest, and that they produced a burnable fuel for derived energy, and that was sent to a commercial incinerator. That option is no longer available to us, so we are looking at a second option now, which is going to a consolidation facility in Rhode Island, and they are shipping it up to Canada for chemical destruction. We are still getting more information on that. It's a fairly new thing for us. Yep. Okay. The Connecticut DEP program, does anyone in our Connecticut program want to weigh in on this one?
Nick, this is Pete Zach from Connecticut DEP. I can cover this if you'd like.
Please.
Okay.
Because it's a great program.
So my name is, thanks. My name is Peter Zach. I'm the director of the Emergency Response and Spill Prevention Division in Connecticut. We have the emergency response and hazmat side of the shop. Some of my other cohorts are in our remediation division and more covering the cleanup aspect of soil, groundwater, and decontaminating the trailers. So we are just getting ready to kick off our take-back program. So we're a little bit behind Massachusetts. It should be beginning in a week or 2 for us. We have a vendor that will be used for the fire departments to contact and then schedule pickups from their facilities to pick up their foam that's in containers, not in the fire apparatus at this point. The foam will be collected and it's going to go to a landfill. We selected a landfill option in Canada. We expect, as you can see, 40,000 gallons. This is not just a C8, but this is any C6 foams. And obviously we did want to get out what we preferred, what we recommended for our foam trailers, so that the fire departments could choose which foams they might want to replace before they give up their old foam. Many fire departments already have either shelved their C6 or C8 foam and purchased new foam and are waiting for this program. Again, we think this will be done over the spring, summer, but like Nick said, there's always probably some late bloomers that will find stuff and we'll need to have a later pickup. The other challenges are, that we had as, we came later to the game is really selecting what the disposal method would ultimately be. We looked at incineration, but there are some issues that EPA has with incineration, so we didn't go that route. Storage is problematic if you want to store it for a later treatment option that might be more palatable. Citing that and the cost seem prohibited. So again, that's why we selected landfill. And I think that covers that slide, Nick.
Yep. Okay. So as Peter mentioned, the next phase that we're looking at is the decontamination issue. The current best management practice that we've been using is to do a triple rinse with water and dispose that triple rinse with the foam. Anecdotally, and I'd like to talk to Raj about a bit more of his data on this, is that the residual PFAS may actually bleed out of the containers, out of the piping, the trucks, the trailers, whether they're steel tanks, probably much less of an issue. If they are poly tanks, it may well become more of an issue. We are dealing with another chemical in another in a pesticide sense, where the pesticide is not an issue, it's not a PFAS issue, but the container that it shipped in actually was made with some PFAS in it. So, it's getting to be a challenge. We're also planning on doing a little bit of benchtop decontamination experiments with some sample legacy foams and probably some of the current foams as well. The intent is to find something better. We've done a lot of internet research. We've reached out to lots of other consultants, companies, to see what they have, what ideas they have. And this seems to be an area which would be ripe for a lot more research. We're going to try some mixtures of ethanol and food grade glycol and see how well that does for stripping out the PFAS out of known contaminated firefighting foam. But we're always open to other solutions here. This is when I'm saying it's benchtop chemistry, this is really good old-fashioned field chemistry, trying to do our best on figuring out solutions from being on the ground. So in conclusion with this, the F3 foams, the fluorine-free foams, are a vast improvement over the legacy foams, and also an improvement over the modern AFFF foams, which are again better than the legacy foams. Documenting, maybe sampling when the foam is actually used in the field. Fire departments that are currently have current foam, or may even be using older foam, hopefully not. When they use the foam, we're trying to make sure that we have some record that at this time, this location, this was the brand of foam that was used on it, and we are building a small library of this, which we hope to combine with some of our other New England partners. It's also a challenge when we're looking at this stuff and doing the analysis using the drinking water standards. We're talking about the part per trillion levels, and it is a very, very difficult laboratory methodology. But that being said, we need to know more. And one of the foam companies came back to us, because we shared this data with them when they, it's their product, said that they believed some of the fluorine and the chlorine that was showing up in their analysis was actually coming from the city drinking water system. We need to tease that one out. This was a recent insight, but it's possible. So we need to chase that down. So if anyone has any questions, please answer it now, or check our website on the PFAS, or just be in touch. We'd love working on this. This is an ongoing project.
Yes, thank you so much. And just to note, people, this is a picture of foam covering this river in Connecticut. They had a release of firefighting foam from the airport there, and into the stream. So this is that's not just plain water there in that picture. There's quite a few questions, and let's see. So pre-2003, now we heard from Raj that even C6s and things that people started using after 2003 also can have PFAS and long chain compounds in them. So why not take Connecticut's route and just take it all PFAS?
It's a good question. We started off to be fair on this thing, I had a limited budget to start this recovery program, so we wanted to focus on the worst of the foams and see how much that was going to be. And while doing that work was also then to gauge what current foams were also available on site. So, you know, we wanted to take out those legacy pieces. The cost estimate, Pete, what is your projected cost on the total removal in Connecticut?
Well, right now we have a pretty good estimated cost for what we're calling phase one. That's the containerized foam, anything that's not on board fire apparatus right now. And I think it's going to be about $140,000.
That phase of it.
Yes,
So,
yes, for that phase.
So a couple people did note that there are some firms that have some products for decontamination that are out there that are, you know, working on this sort of trying to extract the PFAS residuals out of the equipment. So Arcadis has something, TRS has something. We did a webinar at NMOA last summer, and I think they discussed something that they're working on too, CDM Smith maybe. So, so there are some people working on this, getting it out of the equipment. Let's see. So, Nick, the fire departments that sent back their old foam, the pre-2003, now did they switch over to some fluorine-free, or are they just using the shorter chained stuff?
They are, a number of fire departments and fire districts have been waiting for us to push out this report on the analysis of some of this. We wanted to give a couple of choices. We have to be, in state government, obviously, we have to be very careful about not just offering one option. We want to be able to put multiple options in their hands so they can choose. And a lot of fire departments are still still holding on to their current foam until there is something that is guaranteed better, or whether they have, you know, if they had the emergency, they had that tanker rollover, they're going to use what they have. And when they go to replacements, a lot of fire departments have committed to going to fluorine free.
Okay, so now fire departments aren't required to use the mil-spec foam, but were any of the ones that you tested meet the mil-spec other than the one that has all the PFAS in it that we already know? You know, is any of the other ones meet the mil, or why not do fire departments need to worry about that spec?
Connecticut Fire did, when they were bringing in initial foams to look at, to figure out which ones to look at, one of the foams that was proposed as being fluorine-free was also a mil-spec foam. So there was almost certainly that was going to be a PFAS foam. So if we knew or had very strong inclinations right off the bat, we wouldn't have gone down that road. That foam wouldn't have made the list, the test list.
Because by default, anything that meets the mil-spec is full of PFAS.
Yes, fluorinated.
At this point. Yeah, I think we heard Kate tell us that, you know, the DOD is working on that, but to date they haven't found something fluorine-free that meets their spec.
Right.
Although, you know, what you need on a ship to put something out in a second, maybe you don't need so much on land.
That's a very good point. Through this process, there was some questions about, we were focusing on that fire department going for the motor vehicle accident, the tractor trailer, the tanker, for that kind of typical emergency response kind of world thing. We did not touch the area where you'd have major tank farms, where some of the foams are applied in a substantially different way of bubbling up from the bottom instead of, you know, arcing it onto the flammable liquids. So those we were leaving off the page. Those are privately owned. They know what we're working on. We've been talking with our big partners in the petroleum side, and we're just seeing what's actually on the street for typical ER actions.
Okay. let's see, could you share again the two standards that you required for your foams to meet?
Sure, it was NFPA 11 and Underwriters Labs 162.
And what is NFPA?
That's the National Fire Protection Association. It's an advisory group, international advisory group to the fire service.
Okay. And some people are kind of wondering about Canada, and that there seems like everybody's sending their stuff to. So, can you talk more about? Let's see. There was a destruction technology. Is it photocatalysis using ferrous titanium dioxide with activated carbon? I don't know where they're getting that from, but what's the destruction technology?
So from the Mass DEP side, we've had this change of having to find a different way of handling and sending it. We've been working that with our contractor. I've also reached out to Canada, DEP, EPA for their information and input on the processes, whether these are good actor facilities to make sure that we're not sending it to some, we're sending it out of our backyard into a problem case in their backyard. We're trying to make sure that that's addressed and covered. I'm waiting to get more feedback from our partners in Canada on this. COVID hasn't helped.
Okay.
In Connecticut,
yeah.
We were looking at incineration, but that didn't seem to be a good option for us. So our vendor, we were using our suite of contract vendors and sought proposals, and the vendor we chose has landfill disposal areas in the United States, but they're actually further away from us. So the transportation costs were more, and disposal costs would have been more to go to one of their facilities. Now, ours is not being treated. It's being trucked to Canada, either in its original container or repackaged if necessary. And then in Canada, it will be solidified. And it's a hazardous waste akin to our hazardous waste type of landfill, where it gets deposited, the leachate's collected and incinerated, I think, in the end too. So we did our due diligence like Nick did, and had contacted our cohorts in Canada and checked out the facility, and it seemed to be our best option.
And this is Anna Hagstrom from Connecticut. Just jumping in, as for the photocatalytic method you mentioned, we are following along with advances in kind of methods like that, but they're not currently ready to operate at scale, which is why we ended up evaluating those other options more seriously.
One other thing I want to point out, like Nick, we are trying to monitor foam use currently and mined data in the past. When spill reports were called in, fire department usually calls if they use foam because it might get into a stormwater drainage system or a waterway and impact the aquatic life. And unfortunately, firefighting foam by local fire departments are getting used sometimes inappropriately when they don't necessarily need it, in some small car fires and things. And these could be near residential areas with with wells and whatnot. So I felt it's very urgent to get the foam off the street, so to speak, and get the better foam into their hands. So I don't want to wait for other disposal options. So that was part of our choice and making our choices.
We faced the same issue, and we were also looking at, for example, ethanol in gasoline is becoming a higher concentration additive to it. We're seeing a lot of the more polar solvents because they are the product is a challenge when it spills. So as that is increasing, we were looking at the fire service increasing their foam capabilities. At the same time, we were looking to have them decrease the foam capabilities of the old stuff. So it's been it's a real world challenge on the ground here.
Right. So let's see, there's definitely some more options. Someone wanted to know, this thought about developing a library of of information about when foam is used. I mean, currently or in the past, was information gathered from fire departments about when foam was used? Was anybody collecting that information, or is there an existing repository, or this is all sort of new from now forward?
It's pretty new for us from now forward. I mean, we were over the last few years as this PFAS issue would become a blooming, expanding issue. We started tracking it, talking about it, thinking about it, and adding that extra question when we get a notification from the fire department. As Pete said, they now know that we're very interested in this, so that they call us about that as well.
And this is Pete from Connecticut. I'll add again, we mined our data. Like I said, not every fire department reported when they used foam, but we did have spill report. We have a spill reporting database that goes back to, electronically till '94, and we looked back to that and combed it for anything that said foam and other permeations of foam. Some of them might have been a structure fire, which didn't use the same class of foam, or it was just foam. Somebody observed natural protein foaming on a river way back when. So, it was some work, but we have worked on trying to draw locations where foam might have been used from our spill database. And we do, like Nick said, for going forward, a bulletin went out to the fire departments to inform us when they used foam.
And to tell us what type it is. So send us a photograph of the label, or we'll go out and look at it. Or if there's a question, we'll take a sample out of one of the empty jugs and run that and see what we've got.
Okay. For the solidifying of the foam at the landfill, well, first of all, the solidification is being done at the landfill site. You guys aren't doing it yourselves, but do you know what the landfill, people are interested in whether there's a standard method that has some sort of test results behind it, and that, maybe we could all start working from the solidification.
Yeah, the solidification is happening at the landfill itself. And I think one of my cohorts who's not on the call has that detail, unless Anna, you remember. I don't know the exact process for doing it in the testing of the material to see, how much would leachate from the solidified material or not.
Yeah, I'm not sure either. Diane would know, but I haven't had a chance to look into the details on that.
Okay. There has been a request for people to share the products that are under development or being tested for decontaminating equipment. So some of the commercial products that a few of the people maybe mentioned in the question box, maybe if folks could email me, jgriffith@namoa.org with those, because then I could share those products that people might want to look into a little further. I could share that out with that when I send the email with the link to the presentations once they get posted. So I think people are looking for, decontaminating the equipment. And then this is a question for everybody, but maybe also for Raj, which is how long before this plasma destruction, which seems like, destruction is good, before it's like commercially available, before we can start sending our AFFF to a plasma destruction?
Right. I don't know. So we are currently testing reactor 10 gallons per minute for water treatment, and then there is one scaling up project ongoing, trying to scale up to 100 gallons per minute. So I mean, some efforts definitely going on behind that, but I don't know. Probably you'll get better answers from my advisors who, they're PI, so they can give you more accurate details.
If you need some foam, I can send you some.
We have foams. We have definitely. We have. Yeah, we're testing the system. Just it's matter to, scale up.
Right.
Because it's like,
so we do have another professor from Clarkson presenting June 8th, I think, about destruction. So I think you'll have another opportunity to probably learn about plasma and ask some questions on that. I'm assuming that
Right.
we'll talk about that.
Do you know who?
I'm blanking on her. Michelle.
Michelle. Okay. Yeah. Yeah. So Michelle is also part of. I mean, we are working on startup project. She's involved in most of the project what we are doing. So she has, of course, she's a part, so she knows most of the plasma thing ongoing.
All right. Well, if someone can look into solidification and just, a good protocol for that and share that, that would be great. And then, folks that know about people looking at decontamination of equipment and the different things you might be able to inject into the equipment to draw out the residual PFAS, that would be great to share as well. I think that's most of these questions, and we are right up at 3 o'clock. So I think it's a good time to end. So thank you so much to everybody today for presenting, for Kate and for Raj and Nick and in absence Shannon, who helped put the presentation together, but then also Peter Zach and Anna Hangstrup from Connecticut DEP. So with that, I'm going to end the webinar and thank everybody. Hope everybody has a nice rest of your afternoon. Thank you.
Thank you.
Thank you.
Thanks.
Bye, everybody.